In this video, we consider the graphs of logarithmic functions. Let's review the formal definition of logarithmic functions. For positive a not equal to 1, we have that log base a of x equals y if and only if x equals a to the y power. To rephrase another way, log base a of x is the exponent to which the base must be raised to produce x. Because logarithmic functions are inverses of exponential functions, we can use what we already know about exponential functions to deduce properties of the logarithmic function f of x equal log base a of x. Since inverse functions reverse all ordered pairs, the points 1, 0, a, 1, and 1 over a, negative 1, are on the graph of the logarithmic function. The domain of the logarithmic function is the interval from 0 to infinity, or positive real numbers, and the range is the interval from negative infinity to infinity, or all real numbers. The line x equals 0 is a vertical asymptote of the graph of the logarithmic function. If a is greater than 1, then the logarithmic function is increasing. And if a is a decimal between 0 and 1, then the logarithmic function is decreasing. In either case, the logarithmic function is a one-to-one function. Let's first consider the graph of a logarithmic function with base a greater than 1. In particular, let's sketch the graph of f of x equal log base 2 of x. We start with axes and a coordinate grid, and we already know how to sketch the graph of the exponential function y equal 2 to the power x. Because inverse functions interchange the variables x and y, their graphs are reflections about the line y equal x. We indicate the line y equal x with dashed line. Instead of 0, 1, the logarithmic function contains the point 1, 0. Similarly, the point 2, 1 is on the graph, as are the points 4, 2, and 8, 3. We plot some negative values as well, and we have the point 1/2, negative 1, and the point 1/4, negative 2. All we've done so far is take the points on the exponential function and interchange the x's and y's. Now we can connect the dots to get a sketch of the logarithmic function with base 2. Let's see what happens to the graph of the logarithmic function when the base is a number between 0 and 1. In particular, we'll graph the logarithmic function with base 1/2. First, we'll start with a set of coordinate axes and a grid, and we'll draw the graph of the exponential function with base 1/2. Again, we'll sketch a dashed line for y equal x and prepare to reverse the coordinates of points on the exponential function. We have the point 1, 0 on our new graph, and the points 2, negative 1, 4, negative 2, and 8, negative 3 on our logarithmic function. Similarly, the logarithmic function will contain the points 1/2, 1, and 1/4, 2. Now we fill in a smooth sketch of the graph of y equal log base 1/2 of x. In general, we have two basic cases for the graphs of logarithmic functions. The function f of x equal log base a of x with base a greater than 1 has the same basic shape as y equal log base 2 of x, increasing and slightly flatter or steeper depending on the value of a. For fractional values between 0 and 1, the graph of f of x equal log base a of x has the same basic decreasing shape as y equal log base a half of x did. These graphs illustrate the properties of the logarithmic functions stated earlier. The points 1, 0, a1, and 1 over a minus 1 are on the graph of the logarithmic function. The domain is the set of positive real numbers, and the range is the set of all real numbers. The line x equals 0, or the y-axis, is a vertical asymptote of the graph. If a is greater than 1, then the logarithmic function is increasing, and if the base a is a decimal or fraction between 0 and 1, then the logarithmic function is decreasing. In either case, the logarithmic function is a one-to-one function, and that's going to be important when we solve equations in the next video.